All right, so just announcements. I want to thank everybody for coming tonight, those that are our large in-person crowd, and then everybody online. I did want to thank, first off, Robert from Cloudhesive. He provided some snacks over here for us and has for the last couple meetings. So you want to get up and say anything, introduce yourself?
Not really. I'm just here to support this group. You know, we help people migrate over to AWS. We help people manage their AWS platform. And so I just like help facilitating healthy talks around AWS, around the cloud. And so I always enjoy the discussions and what's being discussed and what's, you know, being educated in these things. And I'm just happy to be here and happy to provide y'all with a little bit of nutrition during these meetings.
Well, one of these I'm convinced we're going to have to do a happy hour like David mentioned earlier, hold it at a pub or something like that. So this is Dave Gorin. He's been very helpful in the past. He did one of our meetups last year and he's come back again. So again, Dave, I appreciate your time. And he was going to be here in person, but he can tell you the story. He's home helping his wife heal. So Dave, with that, I'll let you kick it off and run with it, and we'll go from there.
Okay, sounds good. Thank you. All right, let's see if I can actually present here. All right. First of all, David, I want to thank you for setting this up. You know, I know it takes a lot of work and it's not your job, so it's appreciated for sure.
So, thank you.
Okay. Get going here. All right, so we're going to talk about containing ostriches. Wait a minute. Container orchestration. Oh, okay, that sounds better. Okay. So we're going to talk about container orchestration in AWS, which I've been doing for a long time. So a little bit about me. We'll go over what are containers, why orchestration, what kind of options you have in AWS, what the considerations are, and then we'll do Q&A. I'm really informal with presentations, so if you have a question, don't wait until the end. Feel free to pipe up, raise your hand in the chat, or just speak out. I don't care. Okay, about me. So I have a lot of certifications in AWS, including both professional ones. I am a certification SME, which means I work on the exams. So when you're sitting there sweating through Developer Associate or Architect Pro, I'm one of the people that created those questions or curated those questions. So don't blame me, but we challenge each other as SMEs to make it as comprehensive as we can. We recently had a joke though during the review. We wanted to know if anybody had actually seen one of their own questions on the test because we have to take them. And so far, no one has. So I'm waiting to see what happens with that. So let's see. I've been doing this for 39 years. I've been in AWS for 8. I've been in 6 years for containers. And I started doing COPS in AWS. So I did it the hard way, right? So I did it manually way back when, and then via Terraform before going to EKS and then ECS. Actually, the other way around. And I've been doing a lot of compliance in the cloud just because I've worked in medical and federal financial for a really long time. Okay. This block of gobbledygook happens to be Docker's own definition, literally cut and pasted off their website. And it's very fancy and it's very wordy, and you can read it if you want. I'll send the deck to anybody who wants to see it. This is what a container is. It's not a virtual machine, okay? It's only a facade that looks like a virtual machine. Underneath the hood, it's just creating a private route and a private path for everything that you've installed in the container, okay? It's still using the underlying operating system, the underlying CPU, the underlying memory, underlying everything. It's not virtualizing any of that. It's just creating a facade over the top, okay? And it's good for packaging, right? So there's so many different packaging technologies out there. And, you know, they all have their pros and cons, but at the end of the day, they still rely on things that are installed on the operating system. And so what Docker was trying to do was to break that and make it a little bit more separate so that you could deploy on anything. But typical of anything else, there are still some nuances to it, but it is a lot better than, you know, PyPy or, you know, Java jars or wars and things like that. So it does have some advantages. Okay. And why did it just freeze on me? Okay. Can everyone hear me all right? Seems to have gotten quiet.
Yes.
Okay, thank you. All right, why can't you just run containers directly on the instances? And you would be stunned on how many people I've worked with running in AWS who are doing just this. They literally spin up EC2 instances, static ones, install Docker on it, and then via cron job or chef or whatever, just fire up a bunch of containers. And that's it. You can do that. The only problem is you get to do it all yourself, right? You get to update the instance, you get to maintain the instances, you get to spin up more instances if you want to scale, you get to delete instances if you don't want to scale, if you want to scale down. You have to update them, you have to update Docker, you have to manually figure out some way to copy containers on. And and basically you could do it all yourself, right? So obviously the idea in cloud is to use managed services and not do things yourself, right? I mean, this is one of the advantages of cloud is you don't just spin up your own MySQL database cluster, you run RDS, right? You run Aurora, things like that. So one of the things that orchestration gives you is it gives you that vertical and horizontal scalability. And the horizontal scalability comes from auto scaling groups that are under the hood, right? Which obviously you should all be used to if you work in cloud. And the vertical scalability comes into how many containers and containers of different types it can pack onto a particular instance. So then you get to scale in both directions, which is kind of interesting. Another really important thing that it does is replacing failed containers, right? So if you have a decent health check on your container and it stops responding, it'll delete it and it'll use the image to create another one. Ease of deployment. I mean, obviously when you can literally give a deployment descriptor, whether it's, you know, services and test definition in ECS or a Helm chart in EKS, that when you have to deploy new containers, it's really just a matter of running script, right? And lo and behold, there you are. And then this one, Kubernetes gives you an awful lot of things that AWS already does, but it gives it to you inside the Kubes cluster itself. And there's some reasoning behind that, but we'll talk about that because we're addressing specifically using Kubes in AWS, not Kubes everywhere, right? Because one of the big use cases that a lot of people say for Kubes is that they want to be able to run hybrid, they want to run on-prem, and they want to run in cloud. Well, you know, obviously on-prem, unless you're running vCloud or OpenStack, you don't have the same kind of scalability and functionality that you do, that horizontal scalability that you have built into GCP or AWS. Oh, wait a minute, I said a competitor. AWS. So there's a lot of redundancy between using Kubernetes while you're already in AWS, and we'll get to that. But there's a lot of things that Kubernetes does that's cool. So we'll you know, I'm not going to poo-poo it, but we're going to put it in light of practicality here. Okay, so ECS, in essence, ECS is an auto-scaling group, period. The only difference being there's an ECS agent on all the instances, and it is managing any number of containers running on those instances based on the definitions you gave in your service and your tasks, okay? But under the hood, it's still really just an auto scaling group, okay, with an agent. And that's it. Obviously, one of the cool things about this is you get the vertical scaling and control and interesting things that you can do with containers. And it's still just an auto scaling group, which is obviously a rock solid piece of architecture of AWS. And one of the reasons why a lot of people like ECS is because it's really simple, right? I mean, basically it's, it's basic container orchestration on top of an auto scaling group and you're done. And so for people who come from, kind of deploying your own auto scaling groups, your own web servers and things like that, this is an easy jump, right? And let's talk about a container registry. A container registry is nothing. It's literally just a place you store things. And it could be Docker Hub, it could be ECR, it could be Nexus, it can even be an S3 bucket. There's a lot of things you can do. It's really just a place where your container images get stored. And so don't get hung up on what it is. A lot of people use ECR just because it's convenient, it's there. But if you already have like Nexus or you have the full enterprise version of JFrog Artifactory, you don't need ECR. You can deploy to those, right? So, and I've seen Docker Hub used in a lot of places. So, not that I consider it tremendously secure, but at the same time, it's still there and you can use it. Okay, I put this in here just because this starts to get confusing. So one of the things that ECS does is it has task definitions, tasks, and services. And they really all kind of work together. But in its pure form, you really create a task definition. You have a certain number of tasks running on that definition, and the service just defines which one you're using, right? You can get really sophisticated with it, like if you have containers that talk to each other. And one of the things that I always have an issue with when people do microservices, and I've seen this happen in many companies that I've worked for, is you get a service that calls another service. And there's two problems with that. One, it violates best practice because not idempotent, right? Each microservice should not have any dependency on another microservice. Second, there's a lot of performance for that, right? Because you have a container that has to call out over the network to a container that might even be running on a different instance. So you've got two layers of network abstraction just to get to that other container. And you can suffer big performance hits for it. And there are certain companies I've worked for, like one here in Atlanta that might produce credit data for a lot of companies that managed to put a 100-node cluster generating 3,000 TPS because they had services calling services, calling services, calling services. Didn't work out very well when they needed 300,000 TPS. So not a good practice, right? So even though you have this capability of grouping and creating all kinds of things where services might work together, any microservice architecture will recommend don't do that. Okay, so just so you know, the capability's there, don't use it. There are some really rare exceptions, but the idea is that in a true microservice architecture, you don't do that. Okay, let's talk about EKS. EKS is a lot more complicated because Kubernetes is a lot more complicated, but the advantage is EKS gives you all the capabilities while hiding a lot of the ugly bits. So the container registry, same thing, right? It's ECR, it's Docker Hub, it's whatever you want to use. Same thing with load balancers. You can use ALBs, you can use NLBs, whatever you want. Here's where it starts to get complicated. Underneath the hood, there is actually another auto scaling group running that is the control plane. And the control plane of kubes is 3 instances in 3 availability zones, okay? And the reason why it's 3 and not 2 and not 4 is because the control plane servers have to have quorum, right? So an odd number of them have to be able to agree. So when if you have an even number, right, you can get a 50-50 split, won't work. So with 3, 2 of them have to agree that they all have the right answer, okay? And the other advantage, because since it's not a scaling group, if one of them dies, it gets recreated, okay? Thankfully, that with the scheduler and the API interface and all the stuff that sits in that control plane, you don't even have to think about it because it's all hidden. EKS hides all that for you. But just know all that complexity is still there. It's just managed by AWS and that you don't have to look at it, okay? And then when you get down to the worker part, it's back to being just an auto scaling group with agents. It's still deploying multiple containers, and there is some extra organization running inside EKS, which we'll get to in a minute. But in essence, from a physical architecture point, it's really two auto scaling groups. It's one for the workers and one for the control plane, and the control plane one's hidden from you. Okay, there are a lot of concepts in EKS. So they have a concept called a pod. And a pod, kind of like a task definition, is a grouping of container images, of containers. For that same purpose I was telling you before, in case they share anything where you want to make sure they stay with each other so that they're on the same instance, they are near each other physically, they can share, potentially share disk areas, things like that. That's the capability, but I can tell you right now, I have never worked anywhere where it was a good idea to put more than one container in a pod. So just so you know, capabilities there for grouping, nobody really uses it. Containers, they're just regular containers, right? That's just an instance of a container image that you've created. Namespaces, this is a new concept. So a namespace is literally a logical separation inside the EKS cluster, so that I can have one namespace with a set of pods in it with their own security and their own communications that literally are not talking to one's in another namespace, right? So it gives you the ability to create, you know, say, I've seen where they've done dev, QA, and prod in the same cluster, which I don't recommend, but namespaces would let you do that. Or if you have different app stacks and you want to keep them separate, namespaces is the way to go. Under the hood, namespace is just a label. It's a prefix that goes on the container path so that it just knows they're separate, okay? But it does give you that separation because it also has its own built-in access control called RBAC. And that RBAC is namespace specific. So you can have it running differently in different namespaces with different sets of permissions. Probably half the time that I've done Kubernetes clusters for customers, we have linked them to an external SSO, whether it's IAM, and you can do that with KIAM, which is a set of packages you can install into the Kubes cluster. There's an AWS package, I can't remember the name of it, that will do the same thing. That'll give you that IAM integration. You can also integrate with things like your Active Directory or whatever else you're using for SSO. But you see, a lot of this is exactly the same things that AWS already has. It just has it more at the infrastructure level. Daemon sets are things where you can specify certain containers to stay running or to be recreated or to run in groups of like interrelated tasks. Jobs are very similar to the Daemon sets, same thing. Now we're going to talk about a concept called Ingress Controller. Now, Ingress Controller is a little bit more unique. I've never used Ingress Controllers in ECS, but in Kubes, a lot of times when you have a group of pods or a group of containers that do a particular thing, you know, like say user management, and you end up having 5 different ones for user management, right? For adding a user, deleting a user, updating user, whatever. You'll put an Ingress Controller in front of it. An Ingress Controller is really just a web proxy, whether you use, a lot of people use Nginx. I've used Nginx a lot. Done it with Envoy, which is a Go version of another Ingress Controller. It's another web server. And basically what it's doing is it's acting as an ALB to all of your pods, right? Now, if any of you are any good at networking, you understand you've just added yet another layer, another network hop, and there are performance considerations for that, but quite a bit of versatility, right? If you have Ingress controllers running in your cluster. Okay, as I was alluding to, as we kept going through all this about when it's a good idea to put pods or task definitions together, right? Multiple container images in the same area. These are kind of the conditions that you would do. And it goes over those things I was talking about, like shared resources, they're related to each other, so on and so forth. None of these things are good practices in containerized systems, right? You want the container to be completely ephemeral. You don't want it to have any kind of statefulness. You don't want it sharing any kind of resources with another container. You want each one to be idempotent, which is a fancy word I learned from another architect, and I like to use it. But the idea being is it stands alone and it does not need any other resources. Now, if there's something else that it needs, it should end up being like a library that's linked into that particular container and then shared as a library with the other containers. If you need to actually have any kind of statefulness of any kind, this is where you should be using Elasticache or DynamoDB with DAX, or something along the lines of a true, somewhat persistent caching system that is external to the app itself. And this is no different if you were in auto scaling groups. It's just that to me, in a containerized management system, it's much more important that it just be an app, whatever it's doing, whether it's web server, business logic, whatever it is, that it shouldn't be relying on anything else inside the cluster. Okay, let's talk about Fargate, which I have recently dug into very heavily because I am working with my day job right now to see if we can use Fargate in medical record keeping. So we're under HIPAA requirements, makes things a little stickier. But I want to talk about what it is, right? So first of all, it's basically serverless in that there's no underlying auto scaling group you have to manage, right? Doesn't really exist. It's all pushed to external resources of AWS, and the only thing you would see is the task definitions, right? You're not going to see the actual EC2 instances running. Advantage to this, obviously, you don't take care of anything, right? You don't have to worry about the container image, the operating system image or anything like that, or instances or networking of your subnets and so on and so forth, right? I mean, all you have to do is just say where you want to put it and say it's Fargate and you're done. There are some limitations. There are some parameters that don't work when you're in Fargate because they don't make any sense. There's only 3 underlying OS options. You can use Amazon Linux 2 or Windows Core or Windows Full, and they're all like 2019. There are some networking limitations. So if you're using different networking types in your containers, which you can do, I think you can only use AWS VPC type networking, and that's the only one it allows. The sizing's a little more restrictive. They only give you like 4 or 5 categories instead of you just being able to set whatever you want. So it is a little bit tighter that way. And there are certain limits on how big you're allowed to make things and how many things you're allowed to combine up. And one of the key points, which I always have to make, is it's outside your VPC, and this makes most compliance people nervous. And we'll get to that in a minute of there's ways to mitigate that. But at the same time, you do have to deal with it. It's not, you can't just say, blithely say, unless you're in an unmanaged environment. And nowadays, I mean, there's very few industries that don't have tight security now, okay? Because there's so many laws governing what we do. Okay. Fargate. The list of limitations is literally 2 pages long, and it made my head hurt just to read through it. There's a lot of parameters that don't work. You can't use Daemon Sets. There's a lot of networking limitations. There's a lot of limitations on deploying it. It was so ugly that I looked at this and went, okay, if you're going to run EKS, you don't want to do it running Fargate. You just don't. I mean, there's no way I would get that past anybody, either a developer or a compliance person, because it strips away like 2/3 of what EKS can do. So if you are going to go EKS, I'd say if someone could get EKS Fargate to work in a client production environment for your employer, let me know. I'd be interested to see. But I looked at it and I'm like, I'm not going to be able to get this past anybody.
Did you see anything it do that would make you even remotely positive on Fargate?
Well, ECS Fargate, I'm really excited about. EKS Fargate, I'm just like, I couldn't figure out how to fit it in there. Here, let's see if I can show this. Do I have my document out? Can you see my document, or am I just sharing the slides?
It's still just the slides.
Oh, give me a second here. I can change my share for a second. Assuming I can actually get to it. Where's it? Okay, you should be seeing my document now.
Yeah, we can see it.
Okay, so here's when the limitations start. And by the way, I cut and pasted this directly out of the AWS documentation. So you're not looking at my gibberish, you're looking at theirs. So here's where it starts. And there's where it ends. That give you an idea? And each one of these is a major limitation. Oh, and I left out all the parameters because it was like 20 people. It was a 20 item list. So that just gives you an idea of just how ugly it is to try and use Fargate with. So basically, some of the auto scaling's not there. Some of the DNS is not there. It does put in some extra things inside the virtual machine that'll give you some performance issues. So it's just a lot of stuff. It was one of those things where I wouldn't want to take an EKS deployment that I had done anywhere else and try and turn it into Fargate. Maybe if you started one from scratch, it wouldn't be so bad. But I mean, this was just mind-boggling to read through this. And I didn't even look to see how many of the parameters would badly impact what you're doing compared to a normal EKS deployment. Okay, so getting back. Okay, when you're choosing an option, ease of use and complexity. And this is one of the reasons why ECS became such a big player for me, even though I've been doing Kubernetes easily 90% of the time compared to ECS. I've only done one production ECS deployment, and that was at a certain company that might generate the weather data for the whole planet that's here in Atlanta. But every place else, it's been EKS. Transportability, this is where that comes in. So ECS obviously is its own little animal and is unique to AWS, right? Whereas EKS really is Kubernetes. It's a full COPS-based cluster under the hood, and you can take your Helm charts and your container images or your kube control files and literally take them to GCP and run GKE. You can run them in EKS, you can run them in COPS clusters you've built yourself, you can run them on bare metal, and it'll all be the same, right? So in that respect, EKS is way beyond ECS, right? Because if I wanted to move ECS, something equivalent to ECS, it would probably be something like Docker Swarm. And, you know, I would say Rancher, but you know, Rancher is now kubes under the hood anyway. So it's just like kubes with a UI. But, you know, like to a non-Kubernetes architecture, you know, if I want to move ECS and do it to something simple, it would probably be Swarm, which, you know, is almost being deprecated. There's so few people seem to be putting work into it, last I've seen. So transportability, if that's important to you, then kubes becomes a much bigger consideration than ECS. Coolness factor. I always love to ask people about this. You know, a lot of people think Kubernetes is cool. I think Kubernetes is complicated. So it really comes down to what's your viewpoint? Because I tend to run DevOps teams and we're the ones that have to take care of that cluster, I always look at it and go, well, you're making more work for me. What are you doing in kubes to justify that? If you're using namespaces, if you're using RBAC, if you have all kinds of special considerations where you need that kind of structured versatility that kubes gives you, I like rock and roll, but I haven't seen many use cases where that was actually the truth. It was more like they just used it that way. Because if I'm already in AWS, I can spin up 2 ECS clusters if I want to segregate 2 apps and just have a load balancer over the top of them, right? Or Route 53, right? So I don't need Kubernetes in that case. I already have vertical and horizontal scaling. I already have security. It's IAM, it's SSM, right? I don't need RBAC, right? I don't need namespaces. Again, I could just create 2 clusters for 2 namespaces. So using kubes outside of a platform like AWS, yes, I see it. It gives you that same kind of cloud versatility. But using it inside AWS, unless I'm hybrid, it's kind of redundant. And that's why for my day job, Clearwave, where I'm the lead infrastructure person, I'm recommending ECS because they're new to containers. They don't need the complexity of kubes. And I don't want to babysit it because my DevOps team is very small and it's a lot of extra work. That doesn't mean down the road we're not going to get sophisticated enough that I'm not going to go from ECS to EKS, but the likelihood of it in the next couple of years is pretty small. Okay, and then Fargate, we went over that. Okay, so ECS Fargate looks pretty cool. The only thing that seems to be the limitation for ECS Fargate, I mean, there are a couple little limitations, but technical limitations, is going to be convincing a security or compliance person to be okay with it. And we'll get to that in a minute. EKS Fargate, I already went over the fact that from a feature standpoint, it breaks a lot of things. And so I'm not sure I could even sell a developer on that, let alone a compliance person. And if any of you have ever worked with compliance people, you have to remember that reading compliance standards is like reading Bible passages. Everyone has their own interpretation. And you may interpret it one way and think it's all right, and an auditor will look at it and go, oh, hell no. So we'll talk about that in a moment, because the fact of the matter is it's not cut and dry just saying I met all the control standards that it said in the HIPAA document for AWS, I should be fine. Well, yeah, you are from a legal standpoint, but whether or not a client will actually accept it's a whole other story. Okay, so let's talk about security and compliance. This is a big portion of my life, and so I've spent a lot of time working standards like HIPAA and SOC 1 and 2 and FISMA, which is federal. And interestingly enough, even though there's a bazillion controls around things like federal, they really come down to these basics for a lot of it, right? We'll cover the vast majority of it is AWS best practices, which is really nice. So we'll go over that. And basically it comes down to the same things you would do in an auto-scaling group or even on a single instance, is that you'd have in-flight encryption, meaning you're using certificates and TLS everywhere. You have at-rest encryption, meaning all your volumes and S3 buckets and ephemeral storage for EC2 or Fargate or whatever is encrypted at rest. So it's encrypted on the drive itself, right? And then for Fargate, as I had mentioned before, because it's running outside the VPC, your virtual private cloud that you control, that you have VPC flow logs turned on, and you might be running Palo Altos on or some other kind of IDS, IPS option. This is running in AWS's infrastructure. And you know, technically you're on AWS's infrastructure too, right? But that perception is, it's not under your control. It's under AWS's control without that extra layer of your control. And I can tell you right now that that makes a lot of compliance people nervous. It makes customers nervous. So one of the things that AWS provides is something called Private Link, which used to be called VPC Endpoints, which is how I learned it. Shows you how long I've been doing this. And the thing about an endpoint like that, basically what it says is that you've created the equivalent of like a VPN tunnel between you and the AWS service. So even though you're running a service like S3 or Fargate that's outside your VPC, your connection to it's private because it's not going over the AWS public backbone. It's going over this endpoint you created, which is like a private connection. Now, for Fargate, because Fargate's only sort of kind of outside your VPC, the private link goes in the other direction. It's for Fargate, which is running outside, to talk to things like your KMS or your database or your anything that it's, any resource that it's talking to that's not Fargate, that's not part of your ECS cluster or your EKS cluster. So in that one's, it's a little bit backwards, right? Because with like S3 is external, and I create an endpoint in my VPC and it's going from my VPC to S3. This is the other way around. So it's a little bit odd, but it's still the same concept. Is I'm saying I have this private tunnel between me and the service, and therefore it's still not in my VPC, but it's a lot more secure because like I have this private connection. Okay. And I've mentioned a couple of times the client perception. It's a very real thing, and I'm sorry, no matter what anybody thinks, I have been blown out of the water at every different security level because an auditor or a CISO or a CTO, whatever, will just make up their mind. They don't like whatever it is that we did. And I can tell you again, when I was at the large company that did credit data and we were going to work for a 3-letter agency in the federal government, we spent a lot of money working with Coalfire and a lot of my time setting up all the security and making sure all our bases were covered. And their auditor came in and they said, I don't like cloud, you're going to run it in your data center. Poof, 6 months worth of work down the toilet. Okay, that happens. And so, you know, don't think that you, just because you checked all the boxes, that it's actually going to work. But it does help to check all the boxes, I'll tell you that right now. Because I have worked for other groups where we're way beyond what they normally have. And so showing that we've done all this makes them feel comfortable. Okay. I love this expression, turtles all the way down. And what that means is when you're doing in-flight encryption, meaning you've got certificates on everything, most of the time you terminate them on the load balancer, right? And so the load balancer is where your external facing certificate actually sits, right? You know, whatever, CNN.com. It sits on the load balancer. Everything behind the load balancer is not encrypted, right? Port 80. Most compliance standards don't like that. They want you to be terminated all the way down to your microservice endpoint or to the Ingress Controller that's in front of that endpoint. Either one seems to be okay, by the way. What kind of certificates? This is an interesting thing, and AWS has recently added support. So you have to use fully qualified CA issued certificates for anything you've got outward facing, right? That's just a given. And, you know, for customer confidence, for legal reasons, all those things, you actually have to have a fully qualified certificate. Now, internally, the trick in EKS and in COPS and a lot of other Kubernetes is they would use self-generated certificates, which is okay. It's encryption, but they're not certified in any way, right? Because you can create them yourself. You can create them on a command line, right? And use them, right? It's just, it's encryption, but it's not certified encryption. So now what's allowed is what's called a private root certificate. And AWS's certificate manager actually supports this, where you can say, my company certifies my own certificates without becoming a full certified authority, right? Which is a ton of work. You can still do it, but just, you can say, for internal certificates, we certify our own. And then you can generate your own internal certificates and use them for everything behind the load balancer, which is nice because you don't have to pay for them, right? You can just create them. And they are fully qualified to your private root. So you don't get any of those errors of saying your certificate doesn't match the host or it was privately created, blah, blah, blah. It's really nice to have this feature of being able to create something for free on the fly and attach it to everything you have behind the load balancer, which would be like your ingress controllers or directly onto your endpoints, which I'm a fan of, by the way, since most programming languages support TLS sockets. And it's easy enough to just put the certificate right on the endpoint. And if I'm not in EKS, I won't bother with an ingress controller for things like ECS, right? I'll just call the service directly. Let's talk about sidecar versus a TLS enabled endpoint. So sidecar is a very popular concept in Kubernetes if you're using one of the service meshes like Istio or Anthos, which are really just two variations of the same thing. It works by putting another container in front of every single one of your containers as a proxy. And it can be running Nginx or it can be running, you know, Envoy, and you can use pretty much anything, use Apache. And the TLS will be terminated on it, and your container will not be encrypted. So your actual microservice won't be encrypted. And that's actually good enough because sidecars sit on the instance that your container sits on. So technically, you're terminated all the way down to the instance, which is considered good enough, okay? There's a huge performance hit for that because you understand you have a container in front of a container. So you basically doubled every single one of your hops, right? So every microservice you call, you're actually calling two different containers, right? It's calling container, which is calling container, and the reply is going through that other container back to who called it. So there's a huge performance overhead for that. So if you're in a high capacity environment, that will hurt. And I can't tell you the number of companies I've been in that thought using Istio would be a wonderful idea, and they loved all the fun features and dashboards and things that it gave, and then they realized their performance dropped right through the floor, and they ended up having to take it all out again. Probably 5 different projects I've been on where that's happened, which is really scary because people like me will tell them right up front, don't do that if you're in a high performance environment, and yet lo and behold, they'll go ahead and do it anyway. So just so you know, service meshes are a great thing and sidecars are a great thing, but there is a price. There are no free lunches. I wanted to show how simple using Java and Jersey for, you know, so JAX-RS is to do a containerd version of it. You're literally looking at it. It's like 10 more lines of code in your initiation of the server. And that's it, of the service, which in this case running Grizzly. So, and that's in Java, right? So it's quite simple to add TLS endpoints to anything you're doing. Okay, let's talk about at-rest encryption. Now, at-rest encryption in the bad old days, you actually had to encrypt your database or encrypt your tables or encrypt the files on the disk. All of the standards I've worked with, even all the way up to FISMA High, which is top secret federal, will allow you to do volume level encryption, hardware level encryption. And the great part about it is it's invisible to you, it's invisible to the developer, it's invisible to people querying the database. So you have your encryption without you having to deal with it at the application level, right? You don't have to have your own keys and things like that. Now, there is one piece to that. You did get, almost always you have to use a CMEC, which means a customer managed encryption key, as opposed to an AWS managed encryption key. So when you first set up an environment in AWS, it's actually running a fair amount of encryption from out of the box. And what they do is they actually generate a key for your account and they stuff it in it. And I think it's one per region because they don't cross regions. But it's a key they manage. It's no different than a key you manage. It's just they created it. So the difference is with a CMEC, you create it. And you can create it in KMS, that is legal. A lot of the standards support using KMS as a valid high security store, or you can use hardware HSMs, or you can do it on the command line using OpenSSL. I mean, there's all kinds of ways you can do it as long as you generate the first key. It's really all it is. So, I mean, it sounds an awful lot messier than it is. It's not. You generate the first key and you're done. There's usually a key rotation requirement for using encryption keys. And obviously the fun part about KMS is it's built in. You can just tell it what the rotation is. I've seen it as short as 90 days for things like FSMA High, and normal is about a year. So, and you can set it to whatever you want. But having key rotation is obviously a good idea. The fun part about this is, you know, you don't have to do anything once you set it up, which is one of the things I love, right? Because it's built in. Drawback, you have to be careful about things like backups and snapshots because they're either unencrypted or they carry the same encryption key. And so you have to be careful if you're rotating keys, you don't go deleting keys, things like that. You do have to keep track of them. So it's a little bit of work, but it's not tons. Now, looking into Fargate, I didn't know this until this evening, by the way, when I started researching encryption in Fargate. Fargate doesn't really have a hard disk, right? I mean, because you're not running on an instance, right? It's your task and its containers are literally running in, you know, a kind of a segregated space, like a container within a container. But at the same time, if you're kind of like writing temp files to temp storage or something like that, inside that container, it still has to be encrypted. And Fargate doesn't support that, but it only supports it with its own managed keys. And so for certain standards of compliance, they won't allow this because that's a key that's managed by the cloud provider and not by you. Okay, so it really depends on which standard and which auditor you're talking to, because some will allow it, some won't. You just know that if you're going to be working in a compliant environment, this might not pass. It may pass. It's like right now for the HIPAA standard, I could actually run this exactly as this. I could use Fargate managed keys, ECS Fargate, and I would be HIPAA compliant. All it takes is for me to get in front of one of these big medical customers and have their CISO go, sorry, you have to be customer managed. I don't care what the standard says. And then suddenly I can't use Fargate anymore. So just so you know, if you're doing compliance type work, you just have to be careful that, you know, everybody's interpretation is a little bit different. And that's pretty much all I had. And I am open to questions. I know it's a lot of information.
Maybe questions here?
Yeah, I have a question. Can you hear me, David?
Yes, I can.
Okay. So if we were gonna run it, you know, you talked about not wanting to have, you know, persistent data stored, you know, on our containers. But if we did need to hook this up, like our containers, to like a database or something like that, how would you do that?
Okay, hooking up to a database is no different because it's external, right? So your container is literally just working like a normal app. It's just opens up a database connection. It pulls its secrets from AWS Secrets Manager or Parameter Store or wherever you decided to stash the access information, right? Hopefully you didn't put a config file inside your container. though it's been done, that's a security violation. And then you just access your database, right? Now you still have to put the same roles on the ECS cluster that you would put on an auto scaling group or an instance so that it can actually talk to the database. But beyond that, it's still just a database. The thing that blows everybody up is when they say, I've got container X and container Y, and they have to coordinate their actions so that I'm writing a temp file to disk that they're sharing, which you can do in containerization, right? You can make sure they deploy together and you can have shared space. That shared space is the part that I'm saying don't do, right? You don't want a container having to talk to another container to coordinate with another container via something that's inside the cluster itself. If I have to coordinate state or something like that, then I should be using SQS, I should be using Elasticache, I should be using a database. It should be external to the cluster itself.
I guess for the data you were talking about, potentially it could be just persistent volumes created to associate with containers as persistent volume claims, and that can stay as long as you want it until you explicitly destroy them. And there's a different drivers you can use, EFS, etc., as the underlying storage directly as to provision the persistent volumes.
Right, exactly. Right. That's a very good point, is that basically every container should be considered ephemeral, right? Unless it's in the middle of a transaction, you should be able to blow it away and nothing happens, right? If it's maintaining some kind of state that when it creates a new container, it doesn't know what the old container was doing, and now it's lost, that's a no-no in an auto scaling group. It's even worse in a container orchestrated environment because you've got more containers coming and going than you do in an auto scaling group. Because like an auto scaling group, it could stay fairly stable and you get away with a trick like that, right? I mean, I can't tell you how many companies I've dealt with where their logging is only periodically written from the auto scaling group to whatever their logging system is, whether it's Elm or CloudWatch or whatever. And so what happens is an instance dies and you lost the last 30 minutes of what it was doing, right? And I see the same thing in container managed environments where they're logging internal to the container and then periodically writing it out, and they blow themselves up. So the whole idea is there shouldn't be anything happening in that container that if you lose the container, you lose something important.
How about online? Anybody have any questions online?
I guess just a quick comment to what Dave said earlier about pod versus container. It's certainly much almost ubiquitous to see one-to-one use case. Right before I was late to come here, I was troubleshooting something. It just so happened the Con Enterprise API Gateway Management pod actually had 3 containers inside. It just happened. One of them was apparently it's trying to check database is ready or not before it spin off the proxy, then spin off another container. So basically it's a bootstrap for itself within a pod. Certainly.
Right. Because they actually had a dependency between containers and shouldn't have had, right? And this is where you blow yourself up. Now, when I say you shouldn't have, I mean, that's like living in a perfect world, right? Yeah. If you're migrating an app from on-prem and you containerized it, or, it came from a more static container system like Meson or Swarm, then you may have to combine things into pods because it's the only way to get it to work, to make sure that they deploy on the same machine and they stay together. But the idea is that in a perfect world, if I'm writing a microservice architecture from my monolith, I want to make sure that I don't have to use more than one container in a pod or more than one container in a task definition, right? Because then now I've created dependency where if one goes down, I break the other one, right? So now I've got a deployment issue as well, right? I can't deploy an update to one without deploying the update to the other, or I can deploy one and break the other, right? So you're literally asking for it by combining things up like that. But there are circumstances where you moved something, it has an interrelationship you can't get rid of, you're stuck, you're gonna have to do it. But the idea being, if you do have a dependency, you play it smart. It's in Elasticache, it's in DynamoDB, it's in a database, it's out of the cluster itself.
Anybody else? Well, Dave, I think there was a question if we can provide the slides. So I don't know if you have a shareable version or a link that we could post out there, or if you want to send it to me, I could possibly make it shareable, but we will share the video online for anybody that wants to either miss part or wants to go back and watch something. But Dave, thanks again for your time. Yeah.
Sure, my pleasure. I'll put it in an S3 bucket and I'll serve it out. I'll send the link. So if you can just send me the attendee list, I'll make sure everybody gets it. Or I'll send you the link and you can send it out.
Be happy to.
One quick question, not regarding to Kubernetes, but since you're working in the compliance world, working through audits and such, many times people focus on S3, encryption, etc., focus on transport for CloudFront, but they don't necessarily think about the space used to cache objects for CloudFront. Storage is actually encrypted. Who's managed the key? Have you ever run into that?
Yeah, you're going to get hit everywhere. So, you know, actually one of the exam review questions that I got wrong during a review, so hitting or seeing a whole room with subject matter experts, and I got it wrong. Redis supports at rest encryption, Memcache does not. And so when you use an Elasticache, technically it's all in memory, and you can skate in a lot of the compliance ones because being in memory never got written anywhere. But I have seen arguments where they're like, well, if someone, you know, gets into it, all you have to do to access Memcache is to telnet, and lo and behold, you're there, which is true, right? But, you know, again, this is get into that, you know, almost religious debates where basically the rule is don't store anything anywhere where someone could see it, even temporarily, right? And anytime you are going to do that, you leave yourself a gap where a compliance person might bust you for it, right? So in this particular case, even though Redis and Memcache both store in memory, and Redis is the only one that writes the disk and Memcache does not, the very fact that the one supported encryption and the other one didn't is the thing they locked in on, and we had to use Redis. So it's just one of those things where you sometimes you just have to look at it and it makes your jaw drop, right? Another one that came up a few years ago, and I was actually working with a CISO at the time who had to stand in front of Congress because of this breach. We were talking about container engines, and the container engine that's behind AWS, which is called Firecracker. Up until a couple of years ago, you could actually deploy a container, and because it was Fargate and was shared infrastructure, I could peruse memory and see your container and its memory, okay? Which drove auditors bananas, of course, because obviously I didn't even have to be in your account. All I had to do was accidentally be on the same infrastructure as you. They've since hardened it quite a bit, so it's a lot closer to what the hypervisor is that, you know, AWS uses and everybody else uses, which is Zen, variation of Zen, so that it can't do that. But at the same time, those are the kinds of things that come up. So, you know, in the situation I'm in right now where I'm doing HIPAA, I may have to go to a big client that they're trying to land. And if I say, well, I'm using Fargate and I'm potentially on shared infrastructure versus ECS, where it's my own instances and my own VPC, they may say, no, I don't care that it's HIPAA compliant to run Fargate. You still can't run Fargate because I don't trust it, right? So those are the kinds of things that come up. And so, forget all the manual procedures and the documentation and all the stuff you have to do for compliance. It still comes down to what makes the customer comfortable. And so when I get into fights with other architects, and they're like, well, it meets the standard. I'm like, so what? If the client doesn't sign the check, who cares? And that goes all the way up to federal. So I've done federal 3 times now, and I can tell you that it's been different all 3 times for the same standards. Just, everybody has their own opinion of what's important and what's not. And and like I said, I did it once where 6 months worth of work went down the tubes because at the end of the day, they said, I wanted it in a physically secured data center. And that was the end of that.
Does it matter that it was a public cloud versus gov cloud or anything, or is that's out of the picture?
Nope, they didn't care because they said it doesn't matter. AWS owns it and they can look at it. Which, to a degree is true. I mean, because I'm creating a customer managed key, but I'm putting it in a tool they own. Right? And you have to take their word for it that they're not looking at it, which is true. I mean, because there is a hardware HSM under there that they're actually putting it in. But the fact of the matter is, there's no guarantee that they didn't intercept the traffic when you were uploading your key.
Have to share
We can do a whole separate thing on compliance. If you want to talk about fun and games, and if you want to be employed for the entire rest of your life, go into DevSecOps. I can tell you right now that to hire DevSecOps people is hen's teeth right now. You could go anywhere in the world, any major city, and have a job for the rest of your life if you are willing. Now, keep in mind, you get to deal with auditors and attorneys and read through legal standards created by the EU and America and different states, which can make blood come out your ears. But being good enough to translate that into actual code or actual infrastructure is really difficult. Once you learn it, it's not that difficult, but the learning curve's a little steep. But I can tell you right now, if you've got a background in infrastructure, you have a background in programming, and you go into DevSecOps, you'll be employed for the rest of your life.
Anybody else?
And if you guys want me to do a separate one on compliance, I can do that. If you want to see what it really looks like, I can show how that actually grows up, because I've worked with Harden MC and Coalfire for federal, and I've done state work and medical and e-commerce, so a lot of interesting stuff.
Dave, maybe later in the year we'll take you up on that.
Cool beans.
Maybe to last bit on what you just mentioned about infrastructure as code for ECS service as well as EKS service you manage, or if you are seeing how to aid compliance as code. It's like that, maybe use Terraform, would be the chef, or because maybe it's like that your infrastructure is provisioned as such, you can show proof as part of your code. Generally, the provision of the infrastructure as well as show proof is provisioned to comply. Is there any particular toolkits that you see are, I guess, you like more than others?
So lately I've seen Open Policy Agent a lot, right? OPA. And the reason being, OPA is a good open source tool, and you can inline it in things like Spinnaker and Jenkins and things like that into your Terraform jobs. To look at compliance. But the problem was it was kind of like a blank slate. And I can't remember if it's Capital One. One of the huge financial institutions released their entire compliance set as open source for OPA. And so it went from being, only the freaks who are willing to buckle down and do all the work themselves to being really popular because you had this, multi-billion-dollar financial institution release their rule set. So OPA is really popular. I've used Evident, which actually is now called Prisma and is part of Palo Alto. I've used Palo Altos, which are incredibly expensive, but if you want to make an easy prove that I've got a secure network to a federal agency, paying for those Palo Altos is not a bad move because they're okay with them. But I mean, literally, they cost 15 grand a pop for the virtual devices. You need at least 2, and then you have to pay support on them, which is also pretty high. But to get you out of showing your network security for IDS, IPS, that's huge. What else have I used? I've used Dome 9 in banking, and that was actually pretty good. A little busy on the UI, but good product. Again, not cheap. I've also used Alert Logic in banking, and that was another one where, these are external services, but they all have high ratings for different compliance standards. And there's a fair amount of open source out there, but I can tell you right now that a lot of my compliance is code for infrastructure. I ended up writing in Python, and we custom wrote them because we wanted our own rules and we wanted our own basically compliance as code, and so it ended up becoming an entire group. But there are tools out there that will get you a lot of the way there. Even AWS Inspector will give you a good head start. So if you use AWS's tools, so Guard Duty, Inspector, Access Manager, I think if you use those 3, you actually are pretty well on your way to getting a lot of stuff done.
You mentioned about Inspector, I guess, go through Log4j, scanning, etc. Inspector return a lot of the old images still vulnerable, of course. So just, I guess, in my previous jobs, we never able to solve the problem to who's supposed to purge the old images inside ECR, because hypothetically, Inspector is responsible to tell you, because they have no idea when you may deploy one of them back out to service.
Well, okay, so let's talk about, I know we're going off on a tangent here, but I'll mention one thing. The biggest part about compliance is not the technology. It's can you prove you did it? And so there's a lot of stuff that's associated with process, and there's a lot of things that you use to help that are technology to back up to prove that you've done your process. So I use CloudTrail. It'll show everything that got deployed and everything that got changed, right? I'll have VPC flow logs turned on so that I can show everything that went in and out of my VPC, right? I'll have load balancer flow logs turned on so I could show what went to a specific app based on the fact that I had it on a particular load balancer. So there's a lot of things that you can do around that, right? I'll be scanning my Terraform with OPA or my own Python scripts to make sure that prior to deployment, all the tags are done. It didn't open up port 0 or didn't open up 22 to the world. It didn't violate any of my network standards. I've got SCP running in my root account that's enforcing all kinds of rules so people don't deploy stupid things manually into the environment. So there's a lot of different pieces to it, but it really comes down to you got to check it coming, you got to check it going, and you have to have a process to prove that you did it. And it's a lot of work.
Also, a lot of money just keep the log there even.
It gets very expensive very quickly, but when you weigh it against, the federal contracts that I've worked on have all been, they've had a lot of zeros in them. So it makes it worthwhile to do that, but they work that into what they charge, right? Now for the fact that I'm with a much smaller company, they're only a $30 million company, there's a lot of that stuff that's for the future. There's no way I can do any of that right now because it would cost more than my AWS deployment to run those tools like that, right? That doesn't mean that down the road, if the VA doesn't come to us, I won't end up doing that, right? But you always have to weigh your compliance against your costs, because it takes a lot of DevOps time, and the tooling is not cheap. And of course, it's constantly changing, right? So there's no one size fits all. But if you have the basics, you have encryption all the way down with good certificates. You have at-rest encryption everywhere that you can have at-rest encryption. And, you're doing some basic hardening to your container images and some basic hardening to your EC2 images if you're using your own. And that you can prove all that, and then you've got good control over your IAM, right? Which normally means you've got it attached to some kind of SSO like Okta or Azure AD or something that's easily manageable and tracks access. And then you don't have things like keys everywhere, right? So like I'm converting everybody to SSM so that I can have no RSA keys all over the place anymore. Because right now, if an employee leaves, the RSA keys are still out there. Even if I terminate them in IAM, I still have to remember to go take those RSA keys off of all those instances. Well, if I go to SSM, then it's connected to IAM, connected to my SSO, which is Azure AD. And now I don't have to do anything. If I take them out of Azure AD, they're gone, right? And those kinds of things make auditors happy, right? When they see that you've covered your bases as best you can. But I mean, I can't tell you how many companies where I could reach their Memcache instances from outside, and I can't reach their RDS databases from the outside. Like no whitelisting, no junk box, no nothing, So having that kind of stuff in place just is like that good due diligence that if you do get caught out, it's not because you did something dumb or you didn't do something. Right now, like that certain company I was at that got breached, they had a long-running instance, and it was Windows, and it was unpatched, and the hackers had months to figure out what they wanted to do. Whereas in my environments, I like to have instances that have a lifespan of no longer than 4 days, and that way, even if it did get breached, they don't have a lot of time to do anything.
Thank you very much.
Sure.
Yeah, Dave, it was you that did the immutable infrastructure one, correct?
Yeah, I think so. I've done that a bunch of times. That's a fun presentation. Hard thing to get to, but it's cool.
Yeah, that was a pretty neat one. So that one's out there on our channel if anybody wants to go check it out. It was pretty neat. So, all right. Well, thanks everybody. We've got a bunch of events that I should be announcing soon. I think all the way up through May, possibly. So we'll get some stuff out there. Glad a few of you came out tonight. And those of you that joined us online, thanks for joining as well. Hopefully we'll see you in person before too long. So
sounds good.
Thanks again, Dave.
Thanks, Dave.
Thank you. Cheers.
Bye.